Hi, in this video lecture, we're going to learn a HackerRank problem titled Insert a node at the head of a linked list, which is from a data structure section and in that linked list section. What are we supposed to do out here? Given a pointer to the head of a linked list, insert a new node before the head. It is insert at the front. And as we know that linked list basically has the data part and a pointer which points to the next node. And here the pointer which points to the next node is called as next. It says that the next value in the new node should point to head and the data value should be replaced with a given value. And we're supposed to return a reference to a new head of the list. The head pointer given may be null, meaning that the initial list could be empty. So we are supposed to write the code for a function insert node at head, right? So insert node at head has the following parameters: singly linked list, and the parameter name is list, and the data, the value to insert in the data field of the new node. Let's try to look into the template which is specified out here. Yeah, I'm using C language to solve this particular problem. You can use various other languages. Our job is only to write the body part of this insert node function. The task of calling this function is done in the main. It's already done out here. It's a complex code out here. Plus, the definition of this structure is already provided. This is just for our reference. So if you want to know in detail about the structure, we can just look at this code here, and we can get to know that there are functions and this type definition, and there is a structure out here called as singly linked list node, which has a data part and it has the next part. It also has some additional functions: create single linked list node, and then print single linked list node, and free single linked list node, which is something which we need not bother about it, because our job is only to write the code for insert node at head, given the two parameters, and we should have a return type single linked list node. I'm going to demonstrate this particular problem using another tool called as Python Tutor, in which I'll try to visualize it and explain you about every statement what we write. I've tried to simplify this as much as possible. So the basic header files, this is for using a printf scanf, and this is for your dynamic memory allocation. There's a type definition and there's a structure out here, and this is the function. Now the question is, how will this function will be invoked and what exactly will be passed, right? In the main, there will be a pointer which will be pointing to the, in the main, there will be a pointer called as head, which will be initially null, and you will be calling this particular function using this name. You'll be passing this head, and you'll be passing whatever data you wanted to pass, right? So here, initially, I'll try to write the code for the function out here without worrying much about the return type. And then I'll try to talk about why do we need to return and what should we return. Okay. So when this particular information is passed here, the first task out here or in any linked list insertions task is first is create a node. When I say create a node, allocate memory for a node. The second step will be to initialize the node. Initialize the node. And the third step will be attach the node to list. Okay, right. How do we create a node? We will be allocating a block of memory with the help of malloc, and for this we need to pass on the sizes of the structure. So this is the size of the structure. Important thing to know is you should not put a star here, because if you do this, you will allocate memory for a pointer, but you need to specify the structure name, not the structure pointer. Now, when you allocate memory for this with the help of malloc, that returns me a pointer, which I need to collect it into a pointer. I'll just try to call it as new node. Whenever you try to allocate memory dynamically, the memory allocation could be successful or it could be a failure. So we need to basically check out if the memory allocation is successful or a failure. Only if the memory allocation is successful, we need to go ahead and then do the task of working with the memory allocation. For simplicity reasons, I'm not verifying if the memory allocation is successful or not. I'm assuming the memory allocation is successful. Next, I'll try to initialize the node. So I need to initialize the data part of the node with the given data, the parameter data. So here, this data refers to the parameter, and this one refers to the data member of the newly allocated node. The same way, I'll also try to initialize the next part, which is a pointer to the next node, as null. So once the node is created and initialized, we need to attach. If the list is empty, in that particular case, that is, if list is empty, your newly created node itself is your first node. So I'll just try to write list equal to new node. Otherwise, I need to say the link of the newly created node should point to your current head. So for that, I'll just try to write new node of next equal to list. So once you do this, then what should we do out here is we need to make this list update to point to new node. List equal to new node. Okay. As of now, I'm not returning anything out here. So let me try to visualize this particular code out here. So I've started a visualization. And here you can just observe in the main, there's a pointer to a single linked list node. And it is not yet initialized, but after executing line number 29, it will be initialized to null. Then I'm jumping inside the function. The function has two parameters, list and data, and it also has the local variable called as new node out here. So your list will be pointing to having the same value as whatever was present in the head, which is 0. And then the data part has the value 12. Now, line number 14 is going to allocate a memory in the heap section, and the pointer new node will refer to that. And you can observe the memory allocation was successful, right? As of now, the data part and the next part of the newly created node is not yet initialized. Line number 16 and 17 will initialize that to 12, the data part, and the next part is null. Now I need to attach. Here while attaching, I'm going to check out if the list is empty. Yes, list is empty. If list is empty, I will just say list equal to new node. So when I do this, I'm trying to make this pointer also point to the same place where new node is pointing to. So new node is pointing to this node in the heap memory. So list will point to this. But what we need to observe here is when I try to say list equal to new node, will it only modify list or will it also modify the head in the main? So let's observe this. Here you can just observe this pointer is pointing to this node here, right? List is pointing to this node. But what about the head? Head, I don't see it is updated. Okay, let me just go back to the main and see that is this head updated? The answer is no, head is not updated, right? Because when you pass a pointer as an argument and inside the function, if you make a pointer point to another location, then the changes will not be reflected back in the calling function. Whereas if you modify the value at address, the changes will be reflected. But here we are not modifying value at address. We are making the pointer point to a new location. Okay. So because of this purpose, what should we do? It is we need to basically return the updated list. So we need to return the updated list, right? That's one. And then we need to collect it back in the main. So we'll collect back in the same pointer variable, which is called as the head. That's one. Okay. So again, we'll also try to learn calling this function second time. The first time when the list is empty, second time when the list is non-empty. You can pass any values. Let us try to visualize this out here. So you can just see head is not yet initialized, so it will be initialized to null, 0. And then first time you call this, okay, create a node, set. Now list is empty, yes. List equal to new node, yes. List is pointing out there. And when I return this, okay, I'll be returning this one, not this portion. I'll be returning this. So when I return this, okay, the head collects that information. When head collects the information, it's going to point to this particular block in the heap. You can just observe head is pointing to that, right? Second time when I call this function, remember, now head was not null. Head was already pointing to this location 2040. So your list will also point to 2040. Now you're creating a new node out here. So new node is allocated in the heap section. it is initialized data part to value 4 and the next is 0. Then I'm going to check out, is the else null? No, else is not null. So I'll come to the else part. So in the else part, I will be setting the next part of the new node to else, meaning this portion which is null out here, this will be modified or updated with this value. This 2040 will be copied here. When you copy this 2040 here, okay, it means this is going to refer to this block, this node. Okay, let's try to see out here. You can just observe this is pointing to this node out here, right? Okay. Now this is also pointing here. This is also pointing here. Well and good. But I know that ls is a local variable, right? So it is not changed, updated in the head. So I need to return this updated ls, which I'll be collecting back in the head now. So when I come out of the function, please do observe all the local variables of the function, the parameters and the local variables are destroyed. So you have head, which is pointing to the newly created node, which is okay, having the value as 4. And the next part of that is pointing to 12. This way, you can call this function multiple times and the node gets added. Now here, I don't need to pass on the entire code to the HackerRank because we just need to write the code for this function. We need to write the code for this function. And one more thing before I could submit the code in HackerRank, what I could also observe here is I could see this code is common here as well as here. So what I will try to do it is, if it is common, why do I need to write separately in if as well as else? Preferably, I would just take this and say, I want to do this if the pointer is not null, that is, list is not null, and I would like to do this if the pointer is null as well as the pointer is not null. So this statement should be anyhow done in the if and else. So I will just try to keep it outside the if and else. And this statement should only be done in case if the list is not null. So I just kept it inside the if, right? So I will just try to run this once more and try to demonstrate. But yeah, yes, you can just observe. I'm just quickly running through this. So you can just observe everything is set out here. So I'll try to take this code of the function and submit it in HackerRank. Take this code, come down here and paste it here. I'll try to run the sample test case. Sample test case passed, and I like to submit the code. Okay, all the test cases passed. I hope the concept is clear. The code is extremely simple out here, but we need to understand the overall concepts. Thank you all.